Okay, look at this question. What mass of aluminum which will be deposited or that will be deposited in the electrolysis of aluminum sulfates? Okay, aluminum sulfate should be Al2 bracket SO4 bracket 3. Okay, that's a typographic error. When a current, so we now are given that our current. So this M is what we are required to find. So let me call it a required data. A required data. And then I is current 0.5. So it is giving data. We're given it. And then when the current flows for time is what? 1 hour. Okay? But make sure all time are converted to what? Seconds. So what is this 1 hour equivalent in seconds? 3,600 seconds. Okay? It's given. Also, it's a given data, but just that it's given in hour. So what you do, you convert your hour to minutes, then to seconds. 60 minutes make 1 hour. So 3,600 is that equivalent 1 hour in seconds. So 60 times 60 seconds give you what? 3,600. So it's given in the equation, given data. So you are giving it. Okay. What else? So you have to find. Okay. Also look at RAM there. It's also a given data. It's given, which is relative atomic mass of aluminium, which is what? 20 watts, 7. Are you with me? Then also Faraday is also given. Okay. Which is what? 96,500. Looking at all these things, looking at you, staring at you. Okay. What you do is using the complete Faraday's law, which is what? M equals to what? Relative atomic mass times what? Current times time upon what? C. That's the charge. Okay. Even though this one is not given, this C is not given, but one can find out that C is a trivalent metal. You know what I mean by trivalent? Aluminum, I mean, is a trivalent metal, being a metal of group 3, whose valency or whose oscillation state in that compound is what? 3, or plus what? 3. That means this aluminum requires 3 electrons before it can be discharged. Are you with me now? So from the valency, that should be aluminum tetraoxosulfates. That is electrolyte Al2SO4 bracket what? 3. Are you with me now? So if you do this, so that means 3 goes to this, 2 goes. So this is aluminum. This is how we got this charge. So it's something that you strategically will find out from the sort given. So it's strategy. So if you don't know this, that means you're not going to get this correct at all. So what I will do, okay, remember times what? Faraday. What I will do is to plug in all these things here. Okay? So since I'm looking for M, I'll still say M is what? 27, not 24. 27 times, what is my I? 0.5 times what? 3,600 my time upon what? 3 times what? 96,500. Then what is my answer? 0.17 what? Gram. 0.17 what? Gram. Try this. Using a current of 4.5 amperes, how many minutes does it take to deposit 1.50 gram of copper onto a sculpture? No, that should be solution. Onto a solution, or is okay. Okay, I'll repeat. Using a current of 4.5 ampere, using a solution of 4.5 ampere, how many minutes? How many minutes does it take? I repeat, how many minutes does it take to deposit 1.5 gram of copper in its solution in each solution, from a copper 2 sulfates, from a copper 2 sulfates, from each solution, from a copper 2 sulfate, then that's the formula. You know, copper 2 sulfate appears to be an old IUPAC nomenclature. So that's a CuSO4, copper 2 tetra August of a 6 solution. So you are given, take copper Cu to be 64.0, Faraday 96, 500 coulombs. Okay, slug that one out. Okay, so let's see, using a current, okay, just let me interpret this using data, in data form. Current is I, so I is what? 4.5 amperes, comma, how many minutes? So time is not given. It takes to deposit mass given 1.50 gram, okay, and then other variables are relative atomic mass, which is taken to be 64.0, and then Faraday 96500. So strategically, from the name of the salts, copper 2 sulfates, meaning that the states or the charge on that substance, that metal, is what? 2. So that means that C is what? Plus what? 2. So with this, using M is what? Relative atomic mass times I times time upon what? C times what? F. Okay, so we substitute, or we make this, what are you looking for? T is solve the formula here. So we now have what? T now is what? MCF, okay? MCF over what? R A M times what? I. So T now is what? M is 1.50 times charge 2 times farad 96500 upon 64.0 times, what is the current there? 4.5. What is time? Is what? 16 points. No, I want the answer before we convert. Yes, in seconds. 1,005.2 what? Second. But that's not going to be your answer, because you already say the answer in minutes. So how then do you convert seconds to minutes? You divide by what? Divide by 60. You divide by what? 60. How many seconds make 60 minutes? How many seconds? Okay, let's put it this way. 60 minutes. Sorry, 60 seconds make 1 what? Minute. Let me put it that way. 60 seconds makes 1 minute. How many of these seconds will now make it minutes? Right? Where will you write this one here? Under the seconds, isn't it? So that means if 60 seconds is 1 minute, that means 1005.2 is equivalent to what in minutes? X. So we say X is what? This times this is what? 1.005.2 over what? 60. What's my answer now? 16 point what? 75 what? You don't even need the answer to be more than 3 significant figures. So you say 16 point what? 8 what? 8 what? Minutes. That's the answer.